Welcome back. We're in part 5 now, and we're talking about parsing. What about if you need to deal with data from various parts of the world? In this case, parsing numbers is not as straightforward. So for instance, this looks good to us. Let's parse this as double. And when we do that, we get a vector of doubles. But what about this? This could have come from Europe. Let's try that. We get error messages or warnings, and let's see what the vector looks like. All right, we have warnings that we didn't get what we expected, which were periods. The parsing functions can handle this with an argument. And here's the argument that we use, locale, indicating that we're going to use numbers from a specific locale, and we indicate that with the decimal mark. So the decimal mark here is going to be a comma, and now when I parse using that, I don't get that same error message, and my numbers look like this, and they've been converted to our locale in which we have periods. The parse number function will ignore non-numeric characters. So look at this, that has $, percent, and a comma, but we're telling it make everything a number, and here's what we get. Here's a real tricky one. This is the same as above, except that the period is a grouping character from Europe rather than a decimal point. So if I say parse numbers, and I get this, if I was in Europe and the period was a grouping character rather than a decimal point, the result is wrong. If we say period grouping mark, we can fix that. Now you see that we have a 524 and 1249 rather than the 5.24 and 1.249 that we used up here. So in Europe, they use those periods like we use commas with big numbers, and we've taken care of that with the grouping mark. Since everything is stored in a file as a sequence of characters, parsing characters is simple, right? No, wrong. Look at how the computer interprets characters. I'm going to show you what the actual raw code is that's being stored by the computer. Here it is. Look at that. That's what's being stored because the computer works in bits and bytes. And so the fact that I look at something and it says Mike Seaman, the computer doesn't have it stored that way. It stores in what are called hexadecimal codes. And we can see the interpretation of a code by using /x. If I look at this first character here, which is 4D, and let's see what that is in hexadecimal. It's the capital letter M. So the computer knows how to translate this 4D onto the screen as an M. Here's my name written in hexadecimal code, and there you see what we get. Now everything's fine if the coding that's used is what is called the UTF-8 standard. But in some cases, you might run into files where that's not the case. So here's an example using Latin 1 rather than the UTF-8 standard. If we parse this using the Latin 1 locale, then we'll see the actual intent of those particular hexadecimal characters. If you work with dates and times, the parse function for dates and times expects you to use the ISO 8601 International Standard. This lists dates and times from biggest to smallest: year, month, day, hour, minute, second. This is all based on the Coordinated Universal Time. Our time zones are an offset from UTC, also known as Greenwich Mean Time, or GMT. So let's parse this. Okay, that's pretty straightforward. 2010, 10th month, first day, and then the hours, minutes, seconds, UTC, or Greenwich Mean Time. This is straightforward, but remember that the read CSV function is going to have to guess at how to parse a line of characters. We can see above examples of functions that it will use, but we won't be explicitly telling it to use those functions like we did above. So when unknown characters are being read, the tidyverse is going to use a function called guess parser. So let's try that. Here's guess parser. It's going to try to guess at how those should be parsed. Ah, logical. That sounds right. Let's see the next one. Yes, doubles. Let's see the next one. Oh, it thinks that's time. What this function does when we use read CSV is it tries all the possibilities for every column for the first 1,000 rows. If it can't find a match, then it keeps it as a vector of strings or characters. This can be a concern for larger files. For example, what if the first 1,000 rows for a column contain integers, but in general, it's a column of doubles? Or what if a column is missing data for the first 1,000 rows? In both cases, we will need to help the read function. Okay, are you getting the idea here that you're so used to getting handed this nice, neat data, but the fact is there's all sorts of messiness that can occur. So to summarize, before we get into this nice little challenge example, to summarize what we've seen so far, is that there are functions being used in the tidyverse that will tell us how to parse characters to turn them into the right kind of data type. And then there's functions in the tidyverse that will guess from characters what the right data type is. So when this sees logical, and when it guesses that it's logical data, then it can use, back up here we had it, let's see if I can find it, here it is, then it can use the parse logical function in order to turn those characters into logical. Okay, you see the process? Step 1, guess at what it is. Step 2, now that you've guessed at what it is, turn it into that. And so read CSV, what it's doing is it's taking a look at your vector that's in your column. And when it looks at the vector in the column, it's guessing based upon the data it sees, it's guessing at what it is. And once it finds it, then it's going to read it in by parsing those characters into what it guessed to be. What is going to happen in RCSV is it's going to look at 1,000 rows to try to make a guess. And if it can't find that there's a particular thing that works for all 1,000 rows, then it's just going to keep it as characters. But if it can find a match, then it's going to use that match. But the problem is, what if the first 1,000 rows contains one type and the rest of it doesn't? Now, if you're wondering to yourself, well, wait a minute, what about all this time we've been using read.csv? What would read.csv do? Typically what read.csv is going to do is give you an error message. That's what it's going to do. You've been using it successfully because we've been using clean data. But if you end up with data that's not so clear, what we're learning to understand is how read_CSV works so that we can help it when we need to. In the next part, we will take on a file that offers us a challenge and see how we can work with the data in order to obtain what we need. I'll see you then.